Hi everyone, and in this video we'll talk about some examples that related to the definition of the derivative. So the first part in this example, you have to prove that limit f of x plus ah minus f of x divided by h equals to a f prime of x. So as you know, this is the definition of f prime of x, so you have to see in this definition that we have x plus h only, and you have to prove that f of x plus ah. So firstly you have to suppose that a variable equals ah. So firstly let k equals a multiplied by h, and consequently we have h equals k over a, which we can write it as 1 over a multiplied by k. Now since h goes to 0 in our limit, h goes to 0, then k goes to a times h, which is a times 0. So k goes to 0 also. Now you have to rewrite the limit with the new assumption, and you will get that limit f of x plus k minus f of x divided by h, and h equals to 1 over a multiplied by k when k goes to 0, because now the limit depends on k. Now since a is a constant in our example and we have 1 over a in denominator, so you can flip it and put it a out of limit, and you will get a limit f of x plus k minus f of x divided by k when k goes to 0. And exactly this is the definition of the first derivative. We have the same as this definition. If you replace k by h, you will get the first derivative. So this is equals to a f prime of x. For the other parts, you have to use this fact to solve the remaining parts. In part B, you have to find limit of x plus h minus f of x minus h divided by h when h goes to 0, and pay attention for all parts. You have to use the result in part A. For this example, you have to add and subtract f of x in a numerator. So the limit will be f of x plus h minus f of x minus h plus f of x minus f of x divided by h when h goes to 0. Now you have to group f of x plus h with minus f of x and group these two terms, and you will get limit of f of x plus h minus f of x minus f of x minus h minus f of x divided by h when h goes to 0. Now you have to split the limit as limit of f of x plus h minus f of x divided by h when h goes to 0. This is the first one, and you have to write the second one. Between them we have subtraction, so minus limit f of x minus h minus f of x divide by h when h goes to 0. Now you have to use the result in part A, and you can see that we have minus h here, so a equals to negative 1. So the first limit is exactly f prime of x minus the second one. It will be a multiplied by f prime of x. This is the result in part A, and a equals to negative 1, so it will be minus 1 multiplied by f prime of x. So we have f prime of x plus f prime of x, and this will be give that the limit equals 2 multiplied by f prime of x. In part C, you have to find limit 3a f of x minus 3x f of a divided by a minus x when x goes to a. Firstly, we have the denominator a minus x, and in our definition we have x minus a, so you have to take out GCF, which is the negative sign. So we have limit 3a f of a f of x, sorry, minus 3x f of a divided by negative x minus a when x goes to a. Next, we have negative sign here, so you can give it to numerator, and it will be limit of 3x f of a minus 3a f of x divided by x minus a when x goes to a. Then you have to add and subtract a quantity, and the best quantity you have to add and subtract is 3a f of a. So you have to put 3a f of a minus 3a f of a. It's suitable to make it as the definition of derivative. So the limit will be, now you have to group this term by this term, and you will get 3x f of a minus 3a f of a. Then you have to group the other terms, put negative here. We will group this one with this one, and you will get, pay attention, we have negative sign here, so it will be 3a f of x minus 3a f of a. Divided by x minus a when x goes to a. Now you have to split the limit. So we'll get limit of 3x. Before we split here, we have greatest common factor between these two terms. We have f of a. Also we have the number 3 is common between the two terms. So we have 3 f of a, this is the common between these two terms, multiplied by x minus a divided by x minus a when x goes to a. Then we have the negative sign here, minus limit. Now what is the common between these two terms? We have 3a is the common part, so we have 3a multiplied by f of x minus f of a divided by x minus a when x goes to a. Now with more simplify, now 3a f of a is a constant, and also you have to cancel x minus a with x minus a, and you will get 3f of a in the first limit minus, here we have 3a, and 3a is a constant, so you can move it out and you will get 3a outside, so it will be minus 3a. And as you know, limit f of x minus f of a divided by x minus a is the definition of the derivative, so you will get 3a f prime of a, and this is what we want to find. In part D, you have to find limit f of 5 minus 2h minus f of 5 plus 4h divided by h when h goes to 0. So you have to add and subtract a quantity, and this quantity is f of 5. So we have limit f of 5 minus 2h minus f of 5 plus 4h divided by h, and you have to add f of 5 and subtract f of 5. Next you have to group the terms. So the first two terms you have to group this one with minus f of 5 and this one with this one when h goes to 0. So we have limit of f of 5 minus 2h minus f of 5, then minus f of 5 plus 4h minus f of 5 divided by h when h goes to 0. Next you have to split the limit, and you will get limit of f of 5 minus 2h minus f of 5 divided by h when h goes to 0 minus limit f of 5 plus 4h minus f of 5 over h when h goes to 0. Next you have to use the result in part A, and you have to remember that f of x plus ah minus f of x over h equals a f prime of a. So you have to determine what is the value of a in each limit. So here we have a equals to -2, and here we have a equals to 4. So using the first part A, you will get -2 f prime of 5 minus 4 f prime of 5, and -2 minus 4 equals to -6 f prime of 5. Now f prime of 5 is given in this question and equals to 6. So you have to plug in 6 instead of f prime. So -6 multiplied by 6 equals to -36. And that's it. Thank you.